Okay, Assalamualaikum. So let's continue on second part of chapter 8. So we are discuss one test. So this is the second test. Okay, second non-parametric test is a Wilcoxon rank sum test. Otherwise, it's a Mann-Whitney. So this test is used to compare the two independent population. Okay, so we are assume the two population have identical shape but differ in location that measure by median. So we are use the normal distribution, which is Z. Okay, and then you have to find the rank and then the mean and standard deviation of the rank by use this formula. Okay, and then you have to know that the rank will be the sum of the rank in the smallest sample n1 and n2. If the first population, the sample is 10, the second population, the sample is 7, so R will be the sum of the rank from 7 observation. If the numbers of sample is equal, so you have to take the smallest sum. Okay, so this is the step to perform Mann-Whitney test. So the first one, you have to state the hypothesis testing, which is the null will be no different, and then alternative is different between two population. Second step is a test statistic, so we are use the normal distribution, so you have to refer to Z table. And then third is a critical value, so it can be two tail, it can be one tail to your left, it can be one tail to your right. Okay, so we are decide to reject hash null if Z calculated on second step is fall in the region. Okay, left tail, right tail. So conclusion, it will based on the hypothesis and your decision. So let's go to the first example on Mann-Whitney. So given that Army and Marine, so you want to check is there any difference between two groups in time, okay, to finish each recruit. Okay, so given that alpha is 0.05, so first of all you have to rearrange first. Okay, so first is a state the hypothesis is a equal there's no different. Okay, and then the alternative is the time recruit Army and Marine is different. Okay, so second step is a test statistic, so you have to perform the time, which is you have to rearrange from the smallest to the largest, which is 28 minutes, and then you have to state the group, is it Marine or Army, and then last you have to rank 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8, the place of okay, 8, 9 and 10 we got same score, which is 15, 15 and 15. So actually you have to plus 8 plus 9 plus 10 divided by 3. That's why the ranking here is 9, 9 and 9. For these data 16 and 16, actually the rank is 11 and 12. So we are sum 11 plus 12 divided by 2, then you get 11.5, 11.5. Same goes to 17, 18, 19. Okay, for 21, you just proceed 19, 20, 21, 22, 23, and 24. So you have to sum the rank for this one is actually for Marine. Okay, it's 106.5, and then substitute to the mean and standard deviation, then you will substitute to the Z formula. Lastly, you will get negative 2.5115, and then third step is a critical value, so exact 0.025, which is 2 tails, so you have to divide by 2, the alpha 5%, it will be 0.025, so it will be positive negative 1.69. So decision making, since negative 2.5115 is fall in this region, so we have to reject H null. And then the conclusion is there is different in time the recruit to complete the course. So this is the task your understanding for Mann-Whitney test. Okay, please upload to your ULEN. And then this is the third test, which is the Kruskal-Wallis test, otherwise we call H test. Okay, so this test is we are using the Kruskal-Wallis when we want to compare more than 2, okay, which is 3 or more mean using ANOVA. ANOVA is an analysis of variance, which is F test. Okay, we are use the chi-square table. So there is a step involved here. First one is arrange, same goes previously for Mann-Whitney, the lowest to highest, and then we have to rank. The second one, find the sum of the rank each group. Okay, so same also like Mann-Whitney, and then substitute to the formula. So we have H formula for this case. So this is the first rank for first group. This is rank for second group, and this is rank for kth group. It depends on how many group that you have. Make sure it's more than 2. Okay, start from 3 onwards, so we have to use H test. So this is the chi-square table, so you have to refer to the alpha and then the degree of freedom here. Okay. Okay, so this is the first example on Kruskal-Wallis, which is H test. So we have 3 brands, which is brand A, brand B, and brand C. So we want to check is there any different from brand A, brand B, brand C by using alpha 0.05. Okay, let's go to the solution. So first of all, you have to state the hypothesis, which is there is no difference in the amount of potassium contained in the brand, and then the alternative is different. Okay, there's a difference between 3 brands. Okay, and the second test statistic we have this is amount. If I'm not mistaken, amount. Okay, so you have to rearrange from smallest to the highest, 8.2, and then brand 3.2 is a come out from brand A, then got brand B, and last one is C. So you have to sum each brand, okay, the rank of each brand. For example, A, we have to sum the score of the rank is 15, B we get 53, C we have 52. So you just substitute to the H formula. So make sure here is N, okay, R1 square over N, R2 square over N. If there's an unequal observation, doesn't matter. If N here is 4, so it will be 4. So it will get 9.38 for second step. And third step is a critical value. So we have to refer the chi-square table, alpha 0.05. And then 2 degree of freedom, which is k minus 1. K is the numbers of groups. So since we have 3 groups, A, B, C, minus 1, we got 2. And then the answer is 5.991. So it will be the critical value. So since 9s fall in this region, so we have to reject H null. So the conclusion is there is difference in the amount of potassium contained in the brand. So this is the test your understanding question for Kruskal-Wallis question. Okay, there are 3 group and then test at alpha 0.1. You have to upload on your ULEN. So that's all for the second part of chapter 8, which is 2 non-parametric tests. Okay, we have another one last part of chapter 8. Thank you, class.